Okay, good day everyone. This is Teacher Justina, and before I will be discussing my topic for today, those who are not yet done subscribing, please do subscribe, hit like, and do not forget to hit the notification bell for more videos to come. Our topic for today is all about loss of exponents, as we have known that exponent is a symbol written above and to the right of a mathematical expression, the so-called base, to indicate the operation of raising to a power. So as you have seen, the different examples, okay, there are exponents which are numerical and there are also exponents which are algebraic expression. In other words, as it is defined, it is just a symbol. So it could be a variable, and then at the same time, it could be also a constant. Okay, let us explore this following expressions. Let us try see how this each expression is being expressed to its exponential form. Number one, that is now quantity of x to the power of 5, or it could be written into x to the power of 5. Well, number two, it's quantity of a plus b to the power of 3, because the a plus b there is a common base and being used as a factor 3 times. Well, number three, since the m to the power of 2 is a common base, then we come up with the final answer, which is quantity of m squared to the power of 5. Well, number 4, the 5 there is being used 4 times as a factor, then we're able to come up with the final product into 5 to the power of 4. Several examples. So we are talking about uh, the rule, the pattern, the law, no? So let us now proceed to the loss of exponents. So as you have seen in number 1, it is being answered into x to the power of 5. And then this means that x as a base used as a factor 5 times, then it gives a product of x to the power of 5. Well, number 2, the a plus b as a factor is being used 3 times, thus we'll be having a product of a plus b to the power of 3, or quantity of a plus b to the power of 3. And number 3 means that the m squared as a base used as a factor 5 times, and it gives a product of quantity of m squared to the power of 5. Well, number 4, the 5 means as a base used as a factor 4 times, and it gives a product of 5 to the power of 4. Now let us familiarize the laws of exponents. But this video, we will be only tackle, or I will be only tackling the first two, no, the first two laws, the product of powers and the quotient of powers. There will be part two of my video, and this will be all about the rest of the laws. So to summarize the previous examples that we have, we are going to come up with a general rule, and this is what we call the product of powers law. So as to explain the first law of exponents, the so-called product of powers, we simply copy the common base because our base is x in here, and we simply add their exponents. So the general rule says that if x raised to the power of m times x to the power of n, copy the x as a common base, then we simply add their exponents. Because it says that to multiply two exponential expressions with like or common bases, we just simply copy the common base and add the exponents. So let us have the different examples. So letter A, so we simply add the 4 and 8, then it is now y to the power of 12. While letter B, it is 2 to the power of 3 plus 5, because common, the 2 there is common, then we simply add the 3 and 5. So it's 2 to the 8. Well, letter C, we have x plus y, quantity of x plus y to the power of 2 plus 7 is equal to the quantity of x plus y to the power of 9. And please be reminded that if you will answer it in this way, And this will be wrong because the common is not x plus y but quantity of x plus y. So therefore, you should have to be careful of the notation because notation matters. Let's proceed to letter D. So the common base there is m, and for that, we simply add their exponents and it will give you m to the 19. Okay, let us have this remaining three examples of the product law. So remember that we are multiplying, thus the 2 and 3 are both constants, then we simply multiply them. And then the b to the power of 3 and b to the 7 will give you b to the power of 10. So 6b to the power of 10 for letter E. And then letter F, remember that the negative 4 and 2 will be multiplied. And for that, we will be having a negative 8. And since the C there, we have a 2 and a 4 in here and a 3 in here, then we add them because they have common base C. While the B we have there, the 1 understood a 1 and the B here has a 3. Therefore, we have 1 plus 3. And for the final answer, for the final product, it's negative 8C to the power of 9B to the 4. And letter G, as what we have, uh, the base is quantity of 3 over a. So they are common. Thus, we simply add the exponents 5 plus 4 plus negative 5. And we are done with adding signed numbers. So we simply apply it. So 5 plus 4 is equal to 9 minus 5. So we have quantity of 3a to the power of 4. So we are done with these examples, and this will be for the product law. Let's proceed to the next law, which is the quotient of powers law. This time, it is said to be quotient, so we are talking about division of algebraic expression. And for this, we simply subtract their exponents. We are no longer multiplying but subtracting. So there are three cases. If m is greater than n, so the numerator's exponent is bigger than the exponent of the denominator, and of course we will be obtaining a positive exponent. And if m will be equal to n, we will be obtaining a zero exponent. And if m, as in the third case, lesser than n, remember that if m is lesser than n, we can obtain a negative exponent. Let us have number one. So that is, we are going to have the first case. This time m is greater than n. So subtract. Simple subtraction. So 8 minus 2, it will be 6. So g to the 6. Well, number 2, the common base there is 2a. Quantity of 2a, so 14 minus 8. It's quantity of 2a to the power of 6. Do not forget that the numerator's exponent will be subtracted by the exponent of the denominator. Well, number 3, our common base there is a plus b, quantity of a plus b, and then 8 minus 6. Then it will give you the quotient of quantity of a plus b to the power of 2. Well, number 4, we have there the t to the 5m and t to the 3m. Remember, we are not only dealing with a constant exponent as long as we are able to apply the concept that if we are subtracting common bases, if we are dividing common bases rather, we simply subtract the exponent. So that will be 5m minus 3m. That will give you an answer of t to the power of 2m. Well, number 5, so as I have seen, the c there is common. So the c is common. So 10 minus 3, then 6 minus 5, and then 8 minus 6. Then it gives you the simplified form c to the 7, h to the 1, or it could be the 1 is not written, then y to the power of 2. Well, number 6, you have there 4x. 4 is the quotient of 24 divided by 6. And now we can now subtract the 3 and 2 because they are common. 5 minus 3 and 6 minus 4. Thus, it gives you the simplified answer. And then number 7, we have there 2 over 6. You know the 2 over 6 can be reduced into 1/3. And the x there are common, thus we can subtract the 13 minus 2. And since there's no m in the numerator, thus we just simply leave it to where it is from. So the m to the power of 4 is in the denominator, then we just simply leave the m to the 4 in the denominator. So that is our final answer. Okay, so let's proceed to the second case. This time the second case says that if m is equal to n. So meaning if m is equal to n, we will be obtaining a zero exponent. And remember that any base raised to the power of 0, any base raised to 0 is always equal to 1. Okay, so let us have number 1. Of course, v to the 20 minus 20 will give you a v to the 0, and it's equal to 1. Well, number 2, 14 minus 14, and thus x to the 0 is equal to 1. Well, number 3, remember that the 10 and the 5 can be divided, and then the 6 minus 6, the 5m minus 5m, still you have there t to the 0 and c to the 0. And since the t to the 0 and c to the 0 are both equal to 1. Thus, 2 times 1 is equal to 2. Well, number 4, we have the 2x, quantity of 2x to the power of 5 minus 5. Same thing, 2x, quantity of 2x to the power of 0. Again, it's equal to 1. And let's proceed to the third case. This time, the third case says that our numerator's exponent is now less than the denominator's exponent. And remember, we will be obtaining a negative exponent. So if it is a negative exponent, remember, it's unsimplified, meaning not yet simplified. So we are to simplify that in this form, meaning we have to have a numerator of 1. The a as a base will be copied. The negative n will becomes positive n. So let us try number 1. So we still apply, we subtract still the exponents as what we did in the first and the second case. So 8 minus 10 and 6 minus 12 will give you y to the negative 2 and g to the negative 6. Remember that this one corresponds to this one, and then the g to the negative 6 will correspond to this fraction. Overall, applying the law of multiplication of fraction, so it's 1 over the y squared then g to the 6. What about number 2? So again, the 5 and 5 to the 7 and 5 to the 10 are both common. Thus, we just simply subtract. So 7 minus 10 and 5 minus 13, then it gives you 5 to the negative 3 and then m to the negative 8, and then they are both having a negative exponent. Thus, this will correspond to this fraction, and the m to the negative 8 will correspond to 1 over m to the 8. Applying the law of multiplication of fraction, we simply multiply both 1 times 1, and then 5 cubed is equivalent to 125 because 5 cubed is equal to 5 times 5 times 5. So 125 m to the 8. So that's the final answer. The number 3, you have seen that the 16 and 4 are both constant. So 16 divided by 4 is equal to 4. And then we apply the law that we are going to subtract. So c to the 5 minus 2, and then 8 minus 14, n to the power of 8 over n to the 14. So that's it. And then we come up with a 4, which is the constant in here, and then the z cube, and the n to the negative 6, and x to the 0. Remember that have uh, we have the 3 cases: the positive exponent, the 0 exponent, and the negative exponent. So if that's the case, we need to simplify them all. So simplifying them, so 4z cubed remain as is, and then the n to the negative 6 will be equivalent to 1 over n to the 6, and then any base raised to the power of 0 is always equal to 1. And for this, you have already known it that they are having a denominator of 1. So multiply both numerators and denominators, then we have the 4z cubed over n to the 6. Guys, I hope you've learned something from my video, and don't forget again to subscribe, share, and hit the notification bell for more videos. Goodbye and thank you everyone.